Kinematics multistage problems. Suvat formulae. First example. Michael canoes downstream from the launch site, which is here, to the picnic site here, and in this portion of the graph the gradient is positive, representing a positive velocity. The gradient for a displacement time graph gives velocity. And then Michael waits at the picnic site for 20 seconds, and then he canoes back upstream. So he's canoeing back upstream. He's back at the launch site right here, where the displacement is 0. So now he's gone from there to there, but he continues past the launch site to the bridge at the same constant velocity, because the gradient of the graph remains the same. So the distance between the bridge and the picnic site is 1,200 plus 2,400, so 3,600 meters. His speed as he travels upstream, so the gradient of this part of the graph, so we just need 2 points to work out the gradient. So if we take the coordinates for this point, okay, so 60, 2,400, and let's say this point here, and we've got coordinates 120, 0, and then it's just changing y over changing x, so 2,400 minus 0 over 60 minus 120. So minus 40 meters per second. But remember, the question is saying speed. Speed is a scalar. So this minus 40 is giving us a velocity. So the speed would be 40 meters per second. I've added the coordinates for this point and this point on our displacement time graph. So part 3 says we have to draw a velocity time graph. So we need to work out the velocity here, here, and here. In this region, the velocity was minus 40 meters per second, so not speed, but velocity, minus 40 meters per second. And if we work out the gradient for this part, we get 60 meters per second. So these are the velocities for each part of our displacement time graph. So a constant velocity of 60 meters per second for the first 40 seconds, and then reaching the picnic site, Michael is stationary for 20 seconds, and then turning around and going back towards the launch site and towards the bridge. So the velocity now will be negative, and it's minus 40 meters per second until Michael reaches the bridge and then again stops, so now the velocity is 0.